to give it me, depending on the time and where you're watching from. As I welcome you once again to our chemistry class, still continuation of solution to 2025 WAEC past question, day 8. In our day 7, we stopped at question 41, and in this our day 8, we'll be continuing from question 42 down to question 46. Then question 42. 5d orbitals having the same energy level in an isolated transition are described as dash. Option A, we have degenerate, non-degenerate, high-level orbitals, low-level orbitals. Now, just note that we have 4 atomic orbitals, 4 types of atomic orbitals. We call it S, P, D, F orbitals. We need the concept of O-level, but beyond them we still have what? G. S stands for sharp, P for principal, D is diffuse, then F fundamental, and G is geron. Geron, G-E-R-U-D-E. Then S orbital is spherical in shape, P orbital is dumbbell in shape, D orbital is double dumbbell, then F and G orbital is still complicated. Of course, research is still in progress to find or discover their exact shape. Then S orbital is 1 in number, and can accept a maximum of what? 2 electrons. P orbital is divided into 3 degenerates. That is P orbital. This is S. P orbital is divided into 3 degenerates. 1, 2, 3. And can accept a maximum of 6 electrons. If 1 can accept 2, then 3 can accept what? 6 electrons. That is 3 times 2. That will give us 6. Then D orbitals is divided into 5 degenerates. 1, 2, 3, 4, 5. Into 5 degenerates and can accept a maximum of 10 electrons. Of course, if 2 can accept, 1 can accept 2, 5 can accept 10. F orbital is divided into 7 degenerates. 1, 2, 3, 4, 5, 6. Then 7 degenerates. And can accept a maximum of 14 electrons. Beyond here, G orbital is divided into 9 degenerates. And can accept a maximum of 18 electrons. Which means that S orbital is not a degenerate orbital, but P, D, F, and possibly what G orbitals, they are what? Degenerate orbitals. That orbitals, which means there are more than one of different possibilities for the same energy level. So we can have Px, Py, and Pz and rest. That is for P. We have still what? Df. Then the question says 5d orbitals having the same energy level in an isolated transitions are described as that, because the correct option is degenerate. Since they have the same energy level in an isolated transition, the same energy level. So the correct option is A, degenerate orbital. Then question 43. Which of the following oxides is amphoteric? Which of the following oxides is amphoteric? Now, all the compound of what? Oxygen with other elements are known as what? Oxides. So there's nothing like oxygen and its compound. You can have nitrogen and its compound, chlorine and its compound, phosphorus and its compound, but we have oxygen and oxide, because the general name for all the compound of oxygen with other elements is known as what? Oxide. And we have 6 types of oxides. We have 6 types of oxide. We have basic oxide. We have 2 acidic oxide. We have 3. We have neutral oxide. 4 we have amphoteric oxide. Amphoteric oxide. 5 we have peroxide. Peroxide, and 6 we have superoxide. All metallic oxides, which is compound of oxygen with what? Metals, are basic oxide. Example like sodium oxide, potassium oxide, calcium oxide, magnesium oxide, and rest. All of them are what? Examples of basic oxide. Then all non-metallic what? Oxide, which means compound of oxygen with other metals. With other non-metals, is known as what? Acidic oxide. Example, we have CO2, we have SO2, SO3, of course NO2. It can be, which is a multiple oxide that can give us N2O3, nitrogen 3 oxide, or N2O5, nitrogen 5 oxide. We still have PO3 and PO4. PO3 and PO4. So we can have, that is P4O3, P4O6, P4O10, and rest. This is carbon 4 oxide, sulfur 4 oxide, sulfur 6 oxide, nitrogen 4 oxide. This is nitrogen 3 oxide, nitrogen what? 5 oxide. This is phosphorus 3 oxide, phosphorus 5 oxide. All are examples of what? Acidic oxide. And these acidic oxide, they are otherwise known as acid anhydride because of their ability to react with water to produce what? Acids. They can also be called what? Acid anhydride. Then we have neutral oxides. These are those oxides of non-metals that are neither what? Acidic nor basic, which means they have no action on what? Litmus. Whether red litmus or what? Blue litmus, because basic oxide show basic property, which means they change red litmus blue. Then acidic oxide exhibits acidic properties, which means they can turn blue litmus red. But this neutral oxide has no action on what? Litmus. Examples of neutral oxide is the one you know, like water. This is hydrogen oxide, carbon 2 oxide. Carbon 2 oxide, D-nitrogen 1 oxide, which is otherwise known as laughing gas, is also what? A neutral oxide. Then we have other oxides of what? Metals that can react with both acids and base. Can react with both acid and base. Examples, we talk about beryllium oxide, we talk about zinc oxide, ZNO, zinc oxide. Then lead-2 oxide, tin oxide, aluminum oxide like Al2O3. These are examples of what? Amphoteric oxide. These are examples of amphoteric oxide. We have other ones like peroxide. These are still oxide of metals that have higher proportions of what? Oxygen. They say pair of oxygen, like if you have Na2O. This is sodium oxide. If you put 2, it means it has a pair of what? Oxygen now, which means this is sodium peroxide. You can also have hydrogen peroxide, like you have H2O. As you know, as water, this is hydrogen oxide. If you put 2, it's no longer what? Water or hydrogen oxide. It's now hydrogen peroxide. Hydrogen peroxide. You can still have CaO, is calcium oxide that you know. If you put 2, it becomes calcium peroxide. Calcium peroxide and the rest. Then superoxide. There are some oxide of metals, of course, that are super, like Fe3O4. This is iron 2 diiron 3 oxide. Iron 2 diiron 3 oxide. Dilate 2 lead 4 oxide like Pb3O4. Pb3O4. These are what? Examples of what? Superoxide. Now the question is, which of the following oxide is amphoteric? Let's go from the option: calcium oxide, no, that is basic. Magnesium oxide, basic. Barium oxide, basic. Then beryllium oxide. The correct option is D. The correct option is D. One of the assignments I'll give to you is, with a chemical equation show how beryllium oxide can react with what? Acid and what? Base. Drop that in the comment section. Then question 44. The allotrope of carbon used in decolorization of sugar is that. Of course, know that carbon exhibits allotropy. Carbon exhibits allotropy. What then is allotropy? It's a phenomenon whereby an atom of an element exists in two or more forms in the same physical state. Or it can be defined as the existence of what? An element in two or more forms in the same physical state, maintaining the same chemical what? State. Now, there are two allotropes of carbon. We have crystalline carbon, example, diamond and graphite, and non-crystalline carbon, which is otherwise known as amorphous carbon. There are 5 examples of amorphous carbon. Number 1 is coke. We have coke. Then we have charcoal as number 3. Then carbon black, that is number 4, otherwise known as soot, and carbon fiber. Coke, charcoal, carbon black, and carbon fiber. These are 5 examples of amorphous carbon, or what is called non-crystalline carbon. Now, charcoal is one of them, and the one used in decolorization of what? Fruit sugar or sugar is what? Charcoal. Now, the charcoal can be wood charcoal, animal charcoal, or sugar charcoal. Of course, when wood or animal dung of bone and blood and sugar are heated at high temperature and pressure in a limited supply of air, charcoal can be what? Produced. And wood charcoal is used in gas masks for absorption of poisonous gases, and is also used in purification of noble gases. But animal charcoal is used in decolorization of fruit sugar and is used in recovery of industrial solvents. So the correct option here is A. Charcoal is the option. Question 45. In the periodic table, valence electrons are indicated by dash. Recall that the 2 criteria for arranging elements in the periodic table, number 1 is atomic number, number 2 is electronic structure of the element. Now, from the atomic number, you can get the electronic structure using Bohr electronic structure. Let's take for example sodium. Sodium have 11 electrons, since the atomic number is 11, and Z is equal to P and is equal to E. It means sodium has 11 electrons. Now, obeying duplicate and octet rule, the electronic configuration is 281, meaning 2 electrons inside, 8 in the second shell and top. Then this is valence electron. The word valence is a Greek word. In English, it means outermost. So any electron at that outermost shell can also be called what? Valence electron. Valence electron, or the outermost electron. So the valence electron of an element indicates the period of that element. Then the number of what? Electron shells or just shells indicates the period of an element in the periodic table. So which means that this sodium belongs to group 1 because it has 1 valence electron and it has 3 shells. The shell 1 is 2 electrons, shell 2 is 8 electrons, and the third shell is 1 electron. So we have K, L, M, shell. This is 1, 2, 3. 3 shells, meaning that sodium belongs to period 3, group 1. So valence electron is indicated by what? Group number. The correct option is A, group number. 46. Neutrons are subatomic particles which consist of dash. Rutherford 1911 says that an atom is a spherical structure with its weight centered in the what? Nucleus. And the nucleus is made up of what? 2 neutron is a subatomic particle which consists of proton and neutron. And the correct option is what? A. Neutron and electrons, no. Protons and electrons, no. Neutrons, protons, and electrons. The correct option is protons and neutrons, which is a two subatomic particle that is situated in the nucleus of an atom, which is called what? Nucleus. I know you like and you have learned a lot. Do remember to like, comment, and share, and follow Superstar School of Science for more of chemistry lessons. Is there any topic maybe that is challenging in chemistry? Now, give us a name and